Hi guys, in this video I'm going to show you how to write, graph, and solve compound inequalities. Let's talk about writing compound inequalities first. I have an example here where I have a compound inequality that includes x values between -8 and 2, and to write compound inequality for this piece of the number line, I need to include every single x less than 2. And at the same time, these values need to be greater than -8. And since the values in between -8 and 2 have to satisfy both of these inequalities together at the same time, I have to connect these two simple inequalities with the word and I can also write this inequality as -8 less than x less than 2 to include every single x between -8 and 2, not including -8 and 2. Our second example here includes two pieces on the number line. Each piece can be represented by a simple inequality. The first piece is every single x less than -1. And for the second piece, we have every single x greater or equal to 5. And since the values do not have to belong to both inequalities, and the values don't have to be shared by both inequalities, I'm going to use the word or to connect these two simple inequalities because the solution can belong to just one of these two and doesn't have to belong to both of them at the same time. I can also write this inequality as 5 less than or equal to x less than -1. And if I read this inequality from the middle right here, I'm going to say x is greater or equal to 5, x is less than -2. Now let's talk about graphing compound inequalities. I have this compound inequality. I have 0 less than or equal to x, which is less than or equal to 5. I have a compound inequality composed of two simple inequalities. Inequality 0 less than or equal to x. So if I want to graph this piece or this inequality, I'm going to start with the 0. The 0 is included in this inequality, and I'm including every single x greater than 0. Now, for the second part of the compound inequality, I have x less than or equal to 5. That means I need to start with 5. I'm including the 5 because I have an equal sign. So I'm going to start with 5 and I need to include every single x less than 5. So basically, the values that belong to this compound inequality is every single value between 0 and 5, including 0 and 5. Now let's take a look at the second example where we have -3 less than x less than or equal to -5. In this example, again, I have two inequalities. I have -3 less than x. That means I'm going to start with -3. I'm not including -3. I need to include every single x greater than -3. Let's put -3 here. Greater than -3. That's why I'm shading to the right of the circle. My second inequality is x is less than or equal to -5. I'm gonna start with -5. I need to include -5. That's why I'm gonna make a closed circle and I need to include every single x less than -5. So basically the compound inequality consists of two pieces. Um, uh, uh, the first piece is where x is less than -5, and the second piece is where x is greater than -3. Now, solving compound inequality. Let's take a look at this compound inequality connecting two simple inequalities with the word or. So to solve a compound inequality connected with the word or, all you need to do is to solve each simple inequality separate from the other one. So I'm going to start with the first one. I have negative 3 minus 5 greater or equal to 10. To solve this simple inequality, I have to add 5 to both sides of the equation. So I'm going to end up with negative 3x is greater or equal to 10 plus 5 is 15. Now I'm dividing by negative 3 to get rid of negative 3 and isolate the x. That means I'm dividing a negative 3 on both sides. I'm going to end up with x. Now, since I am dividing by a negative number, the inequality sign needs to flip. So I'm going to have less than or equal to 15 divided by negative 3 is negative 5. Now let's solve the second inequality that we have here. We need to distribute 4 times x is 4x, 4 times negative 2 is negative 8. We have 4x minus 8 is greater than 4. So this is again a two-step inequality where we have to add 8 to both sides. So I'm going to end up with 4x is greater than 12. I'm dividing both sides by 4. So I'm going to end up with x greater than 3. So now the solution is going to be x is less than or equal to negative 5 or x is greater than 3. And to be able to graph this inequality on the number line, I have to put negative 5 and then include negative 5 in the solution. I'm including every single x less than negative 5. And then I have to put 3. I am making an open circle for 3. And then I'm shading to the right of 3 to represent every single x greater than 3. I can also write this inequality as x is less than or equal to negative 5, greater than 3. Now let's take a look at this compound inequality. We have negative 5 less than 2x plus 1 less than 3. To solve this compound inequality, the main goal is to have x in the middle by itself, isolate the x in the middle by itself. And if we look at this compound inequality, we see that we have one simple inequality connected with another, a second simple inequality on the right. So, and to solve such compound inequality, we have um, to isolate the x in the middle and apply whatever properties that we are using to get rid of numbers to all sides of the compound inequality. So to isolate the x by itself in this example, I have to get rid of 1. That's why I'm going to subtract 1 from all sides. So I'm going to end up with negative 6 less than 2x less than 2. Now, to isolate the x, I need to divide by 2, which means I need to divide all sides by 2. And when I divide all sides by 2, I end up with negative 3 less than x less than 1. Now, to graph this compound inequality, I'm going to have to start with negative 3 right here. Negative 3. And then I'm not including negative 3, that's why it's an open circle. X has to be greater than negative 3. And then I am gonna graph the second simple inequality. I have x is less than 1. So I'm making an open circle and I'm including every single x less than 1. So basically, the compound inequality is represented by this piece of the number line in between the numbers negative 3 and 1, not including negative 3 and 1.